Hi guys, welcome to Matrices 8. In this session, we are going to see the basics of matrix inverses. So we're going to see what is the meaning of an inverse of a matrix. We're going to understand the basic idea behind it. We will solve finding of inverse matrices in the next video. This video, we're going to restrict ourselves to understanding the basic logic behind inverse. Okay, right. So once again, yours truly, Mr. Srinivas, that's my name, Srinivas Akapati. I'm the Chief Mentor of Career Launcher Bangalore. Right, so let's go ahead with the definition of inverse. Now, as usual, I'll first explain to you the definition of inverse with respect to real numbers, and then we'll carry forward the same idea when it comes to matrices. So the inverse definition in a real number, there are two inverses. One is called as an additive inverse. The other is called as a multiplicative inverse. Additive inverse and multiplicative inverse are both easy for you to understand. Additive inverse says a given quantity when added to its additive inverse result is 0. So if I have x, if I add it with an additive inverse, let's say b, this is the given number, the answer should be 0. So my inverse will be minus x. So if I give you 1025, the additive inverse of 1025 becomes minus 1025. It's a no-brainer, very straightforward, right? Nothing great about it. So that is called as the additive inverse. It's very simple. The additive inverse in terms of multiplication is also not so difficult. Basically, we say that for real numbers, when you multiply a number with its inverse, the answer should be 1. Now, in terms of multiplication, the result should be 1. So, if you take x and multiply with its inverse b, the answer should be 1. Or your inverse b should be 1 by x. So, any number if I give you, what is the inverse? The inverse becomes 1 by that number. So, minus 25, what is the inverse? The inverse is 1 by minus 25. It's as simple as that. Now, remember, inverse for multiplication exists for all real numbers except 0. Why? Because inverse of 0 becomes 1 by 0 and you cannot have 1 by 0 is undefined in mathematics. Right? So please keep that in mind. With that, let's move on to understand the inverse definition in a matrix. Inverse in a matrix, again, the first thing is additive inverse. Additive inverse, the logic does not change. If I have a matrix A, then the additive inverse of matrix A will be called B if A plus B becomes equal to 0. Or matrix B, that is the additive inverse of A, should be minus A. So if you have a matrix A in this manner, then your B becomes negative of A, which is all the terms becoming negative. Because when you add A plus B, everything will get cancelled and the answer should be 0. So if I have 1, 2, minus 3, 6, A, then the additive inverse becomes minus 1, minus 2, 3, minus 6. Because when you add them, the answer will turn out to be a 0 matrix. If you add these two, your answer will become 0, 0, 0, 0. So all zeros, and that is what you want. Right? So that's very easy. Additive inverse is not a problem at all. The problem or the story starts from multiplicative inverse. Okay. So first, for a multiplicative inverse, the first thing you need to understand is whether A inverse is described in this manner. If A is a given matrix, A inverse is written in this way, A power minus 1. That is universally known as in matrices inverse of A. Now, a matrix A inverse will be A power minus 1 is called as the inverse of A if and only if this condition holds true, which means whether you multiply A and A inverse or A inverse and A, the order in this particular case does not matter. The answer should be I. Now I'm saying this is important because if you remember, A into B matrix multiplication is not equal to B into A. But one of the special properties of this inverse of a matrix is it is going to exist in such a way, if at all it exists. We will see how or when it will exist or is it possible for it to not exist also? We will see that later in this video itself. But if it exists, then whichever side you multiply does not matter. The answer should be identity matrix. I is what? I is identity matrix. Here I is not 1. So if I take A to B, and remember, inverse exists only for a square matrix. Inverse exists only for square matrix. So if I will come back to this point, if I say A is a 3 by 3 matrix, if I say A is a 3 by 3 matrix, then this inverse will be a 3 by 3 inverse. The identity will be 3 by 3 identity, which is 1 0 0 0 1 0 0 0 1. This will be your I, correct? So we have to find this A power minus 1 in such a way that when these two get multiplied, the result is identity for 3 by 3. Now there are a few properties about inverse matrices. The first property is, as I said, only square matrices will be having inverses, which obviously means all matrices do not have multiplicative inverse. Non-square matrices obviously will not have inverse. Even in square matrix, not all of them will be having multiplicative inverse. First of all, by logic, when I say inverse exists only for square matrix, it means that non-square matrix will not have inverse at all. Second thing, even within square matrices, it does not mean that every square matrix will have its inverse. Some square matrices may not have inverse. We will see how and when or why later. I already mentioned this, only square matrices are invertible. The Y part of this is something very similar. In fact, it's got to do with the definition of A inverse. The Y part we'll be covering it in the next session. Once I explain to you how to find A inverse, you will understand why. Only square matrices will be able to be invertible. Basically, invertible means you are able to find an inverse. Third is, there is certain cases, it is possible to find something called as left inverse and right inverse. I'll show you one interesting example. Take this matrix 1 minus 1 minus 1. Okay, you have 2 minus 1 and minus 3. Now multiply this with this matrix minus 3 5, and then you have minus 3 3 minus 1 and 2. Now what is the answer? If you do this correctly, you will get 1 into minus 3, which is minus 3, plus, right, minus 1 into minus 3, which is plus 3. That is, I'll write 3 itself, plus minus 1 into minus 1, which is 1. Similarly, you multiply the first row and the second column, you will get 5 into 5, 5 into 1, which is 5, minus 3 into minus, so plus 3 into minus 1, which is minus 3, and 2 into minus 1, which is minus 2. Similarly, if you write the others, you will get 2 into minus 3, which is minus 6, plus 3 and plus 3. And finally, the next number will be 10 minus 3 minus 6. So if you notice, what will this become? This matrix. This matrix will become minus 3 gets cancelled, 1, then 0, 0 and 1. So if you notice, interestingly, this is matrix A, this is matrix B. A into B gives you identity matrix. But if you do, because according to your multiplicative inverse, this basic rule, whether it is A into A inverse or A inverse into A, both should give you I. But in this case, if you call this B as A inverse, there is a problem. Why is the problem? Because when you do it as B into A, you will notice that B is a 3 by 2 matrix and A is a 2 by 3 matrix. And when you actually multiply it, the result you can very quickly see minus 3 5 minus 3, 3, minus 1, 2, multiplied with 1, minus 1, minus 1, 2, minus 1, minus 3. When you multiply this, and this time I'll do it in a slightly different method so that you remember both the methods of finding matrix multiplication. Once again, it's a revision for all of you. So the second method is slightly, it's not a method actually, it's a different way of representing, if you remember from matrix multiplication session. So what do? I will draw a horizontal line and a vertical line. I will write down minus 3 comma 5, then I'll write down minus 3 comma 3, and then I'll write down minus 1 comma 2. So after writing down the vertical minus 3 5, minus 3 3, minus 1 2, that is the rows in the B matrix, I will write down the columns in the A matrix. It will be 1 comma 2, minus 1 comma minus 1, and minus 1 comma minus 3. So the multiplication of these two I'm going to write here, right? And that's the faster way of doing. So minus 3 into 1 is minus 3, plus 5 into 2 is 10. Similarly, I will multiply these two. Minus 3 into minus 1 is 3, 5 into minus 1 is minus 5. And here itself you can notice that this is not 1, this is not 0. So which means if you continue this further, you will get a matrix which is of somewhat like this: 7, minus 2, and something else. Clearly, this is not an identity matrix. This is not an identity matrix. But when you did it as A into B, you got an identity. But when you do it as B into A, it is not an identity. Such a thing is possible. In this case, you will not call B as an inverse directly. You will call it as left inverse or right inverse, depending upon which side you are multiplying it. So in this particular case, you will call B as a right inverse, because A into B is on the right hand side, you will get I. But when you do B into A, when you try to find the left, it is not equal to I. So it is only right side. It is called as a right inverse. It's very interesting. You can get this, but this is not called the identity of A. So only, you can say, half identity exists. That's one way of looking at it. Basically, you say that only the right identity exists for A, the left identity does not exist for you. So when we talk about identity, we don't deal with such a thing. We talk about the basic condition that A into A inverse or A inverse into A should be the same answer. That is identity. Okay, that is what we call as identity. Right, moving forward. The fourth part, or the fourth note which I want you to understand, is non-invertible matrices are also called singular or degenerate matrices, which means a matrix that does not have an inverse is called as a singular. Now this word was actually used in IPMAT 2019, I believe. They directly said the matrix is singular. So if you don't understand what is the meaning of it, you will never understand how to solve the question. So a matrix which does not have an inverse is called as a singular matrix, or the other word is degenerate matrix. Okay, so these are the few points that you have to keep in mind when you're dealing with inverse of a matrix. Now, how do you know? Now we are coming to the point of how to calculate if a matrix is invertible or not. First point, it should be a square matrix. I already told you non-square matrices are not invertible. Within square matrices, if the determinant of the matrix is not 0, then you can find the inverse. If the determinant of the matrix is 0, then you cannot find the inverse. That is a simple thing. So first of all, it is to be a square matrix, and within square matrix, if the determinant is not 0, then the matrix which is given to you will have an inverse. If it is 0, it is not invertible. It is singular, or it is degenerate matrix. It's a very straightforward way of finding out whether it is invertible or not. Okay. Now these are some of the properties of matrix inverses. We will see how to calculate inverse in the next session, but we will stop this session by looking at the matrix properties, matrix inverse properties. Firstly, there will be only one inverse for a matrix. You cannot have two matrices like this: A into B equal to B into A equal to I. You cannot have one B like this, and you cannot have another A into C equal to C into A equal to I. So you're basically saying that B and C are two matrices which when multiplied with A give you the same result. They cannot exist. They will be every matrix, if at all the inverse exists for that matrix, only one unique matrix inverse will exist. You cannot have two different answers. Okay. Next is inverse of an inverse is the original itself. Inverse of an inverse is the original matrix itself. You don't have to waste your time finding out two inverses. This I already mentioned, only square matrices are invertible, but remember, not all square matrices are invertible. Only square matrices are invertible does not mean that all of them are invertible. Some of them whose determinants are 0 cannot be inverted. That's the second point. Not all square matrices are invertible. The next property which is interesting is if you have product of a matrix AB and you want to find the inverse, first of all, if it is existing, then you can write it as B inverse into A inverse. So that the order will change if you bring the inverse inside the bracket. So if I write 1, 2, 0, 3 multiplied with 2, 1, 1, 2. Okay. Now, if I want to find the inverse of this, this is same as finding the inverse of 2, 1, 1, 2 inverse multiplied with inverse, meaning you have to find the inverse of it, whatever the matrix is, multiplied with inverse of 1, 2, 0, 3. In the next session, we will see how to find the inverse of these matrices. Okay. The last part which I want to explain is if there is a matrix A and a matrix X, you are multiplying them to get B. Okay, if you have a matrix A and an X to give you B, you can multiply both sides with a negative or sorry, not negative, inverse of A, but the order of multiplication should be maintained. A inverse is coming to the left hand side, which means right on the right side also A inverse will be coming on the left hand side. Now what happens because of this? By the associative property of multiplication, if you remember for matrices, the property of matrices, A into X you do first or these two you do first, the answer is same. And now you know that A inverse into A is I. So this becomes I into X, which is A inverse into B. But identity matrix into X will always be the original itself. So X will be A inverse into B. Similarly, if you have X into A, so you have to be careful where to multiply. Is it AX given to you or XA given to you? If it is XA, then if XA equal to B, then multiply both sides with A inverses on the right side. So now this becomes X into these two product becomes I, which is equal to B into A inverse. So X becomes B into A inverse. So these are the properties of inversion of a matrix or inverse of a matrix. In the next session, as I kept saying, we will be learning about how to find the inverse of a matrix. Thank you guys. I hope the session was knowledgeable, useful to you. You can always reach out to me on my WhatsApp or my email. See you in the next session.